Hi, everyone. So today I'm going to be talking about Taffy. So Taffy is the UI layouting library that I somehow now maintain. So I'm going to be talking a little bit about that story of how an ecologist and game developer now has a high-performance Rust implementation of Flexbox and CSS Grid in the list of stuff I maintain, and then after that, I'm going to be spending some time talking about the lessons that we've learned and my feelings on layouting and Flexbox and how could we make something better. So without further ado, let's get started. So let's talk about how did I get here. So originally, back in, I think, 2015 or so, Rust needed a UI layouting crate. You have some boxes, you want to go and arrange them. Okay, we'll steal from Flexbox and the web. But so Visly, which was a lovely VC-funded startup, created Stretch. It's steadily improved. It's maintained. Everything looks great. Bevy says, okay, we need a UI layouting library. We want to make UIs for our video games. Let's go just use Stretch. And then Visly was acquired. And you know what happens to startups who are acquired and their products. And that is equally true for their software libraries as well. And so Stretch was abandoned. And we tried to contact the original authors, and radio silence. So Stretch is dead. Why is this a problem to us? Why is this something that we need to fix rather than, it's a layouting crate. Like, things don't change. You lay out things the same in 2000 as you will in 2050, like as long as you're using the same algorithm. But there are some limitations. So first off, I'm not the biggest fan of Flexbox. It's fine, but it's confusing. It has unintuitive behavior. It's really hard for beginners to learn. And there are other things like CSS Grid, which for some layouts, especially things that are relevant to games like inventory systems, are just better. Or what if the community wanted to start to explore more exotic layouting algorithms? But also, Stretch wasn't bug-free. I mean, you're implementing a web spec. It's never going to be bug-free. But this was, especially not bug-free. And you have a lot of these small problems, and it was very hard for us to tell, is this a bug in Bevy itself, or is this a bug in the layouting crate that we've adopted? And just those paper cuts really frustrating users and making our experience worse. Do we go and somehow adapt what we're doing in order to fix the bugs upstream? But most importantly, there was a critical bug. UI layout is notoriously hard to get fast in complex cases. It's very easy to screw it up, and then you're like, oh, well, now suddenly I have an exponential time algorithm. And we had one of those. So as our trees got deeper, it would be an exponential time. And so, it would work fine with depth 3 trees, but if you got to depth 12, it was starting to take, 10 seconds per frame just doing our layouting. And it's like, okay, this is unacceptable for anything, but in a game engine, this is such an unacceptable footgun that we can't ever make a production-ready UI solution built off this crate. And of course, there's never going to get fixed. So our dependency died. What are our options? How could we fix this? Like put on our manager hat. So we could pay them to keep maintaining it, but pay who? We can't get into contact with the maintainer. The company that made it no longer exists. And even if we could, we don't have any money to pay them with. So we could write our own layouting library from scratch, but we're trying to make a game engine here. We're not layout is not our passion. This isn't the thing that gets us inspired and makes us say, oh yeah, I want to do this. And especially Flexbox is very complex and challenging to integrate. And if we wanted to swap to something new, then we're going to break our existing users. We're going to have all sorts of complex things, and we're going to cause the proliferation of standards without having like a really clear argument about why this one in particular is better. It's okay, yeah, sure, your dependency died. Go use a competing library. Well, it turns out Stretch was the only UI layout crate in Rust, like the only standalone UI layout crate. A bunch of other UI libraries had gone and written their own, but they hadn't been so kind as to spin them out into a reusable interface for us. We could use Yoga. Yoga is what C++ uses. It's fast, it's well-maintained, it's reasonably good. But if we pull in C++ into our build chain, then suddenly every user writing Bevy and every user shipping Bevy games has this much more complicated toolchain for something so incidental as a UI layouting solution. So our last option is, hey, you know what? Let's just fork it. Let's fork it and maintain it ourselves. And okay, we have to maintain it, but at least it's no longer broken. And it's MIT licensed. We can just do this. We don't need to ask them for permission. So that's what we decided to do. And so I'm going to talk a little bit about what that process looks like and why I think that it was actually successful. Because sometimes you'll often see talk about, oh yeah, we'll just fork this thing. Just if they do something bad, we'll just fork it, and we'll defy the evil foundation with by making a language with a crab wielding a knife. Like it doesn't just happen. There's actually work involved in terms of making a fork that's going to live and survive and thrive on its own 2 feet. So what we did is I identified existing forks. So it turns out that there was an existing reasonably maintained fork by Dioxys, by Jonathan Kelly, who gave a talk, I believe, earlier this morning. And we said, okay, that looks cool. That looks good. Let's go and think about what we need. And we said, okay, we want a functioning UI layout crate. This is not a controversial or particularly challenging thing. Okay, but this seems like our needs are aligned. So I reached out to them for collaboration. He's like, cool, I would love to share maintainership. So we shared maintainerships, and then we said, okay, we're going to go and we're going to rebrand this to something better than Dioxys's fork of Stretch, something that we can actually talk about and give an identity of its own. And we decided to call it Taffy. And then we said, okay, we're bringing back this dead dependency that you guys may have cared about or may have looked into, and we're going to make it good. So the next step after we've decided to do this is, okay, let's go actually pull back the code and figure out what the heck is going on. And the first phase of this was just reading code and making issues and complaining about all of the questionable decisions that the previous maintainers had made. From what I can tell, it was made by very competent engineers who had never really written Rust before, which was challenging. They didn't have very strong grasp of the idioms. They never used any options or enums anywhere in the code base for some reason, and it wasn't a lot of fun to work with. And so we said, okay, let's go and we'll make this something that that contributors are happy to touch, happy to enjoy, because ultimately, we don't want to be shouldering the whole maintenance burden of this ourselves. And what's the best way to get contributors is to make it not suck for them. So the next phase was, okay, let's go and let's solve the problem that said, oh God, we need to actually fork and start maintaining this first. So the fundamental problem is that layouting is all about walking up and down trees and coordinating between parents and childs. And it's very easy for that sort of operation to become exponential in time, and because you're going up and down the tree, and so you end up with an exponential number of possible paths. And the solution to this is to use caching. You say, okay, yeah, we already know this, we don't need to touch it. But if you screw this up at all, everything just falls apart and becomes exponential time again. And so we sat down and we said, okay, let's go and fix these things. And it turns out there was not one, not two, but 3 different caching bugs that caused exponential time. And it's like, okay, this is why we have these benchmarks, and this is why we go and test it, because then you can actually validate these things and make sure that you can catch these unknown unknowns. You can say, well, does this algorithm have exponential time blow up? Well, it's too complex to like just sit there and look at it and say, oh yeah, well, it's like in your computer science class, and you're like, oh yeah, like, I can see how this would turn exponential. No, you can't do that. It's you sit down and you benchmark it and you draw the graph, and you're like, oh, well, that goes to the moon. I guess that we broke it. So yeah, now Taffy is actually very fast, which is really, really cool. So the next step was, let's go and write some tests. Let's write some bug fixes. Let's make the code better. Let's just generally improve this code base. And so this has been a pretty long and ongoing process, but it's the fundamental challenge here is that Flexbox is not a great spec, and it's not a lot of fun to implement. It's very complex. It's inelegant. It changes over time as new features get added to the web, and ultimately the question of how should this behavior work? You often can't figure out by reading the spec, and instead you have to say, oh well, what does Chrome do? And so all of our tests are not actually like we have some unit tests and some that we can reason about by thinking about like, okay, how should this code work? But ultimately, our test suite is actually this wonderful and terrible beast that generates matching CSS from the Taffy code, and then runs it in a headless Chrome instance, and then goes and checks to see if its results match. And it's like, okay, yeah, sure, that's a way we could define correctness by, bug for bug compatibility with Chrome, which is super cool, but maybe not the most fun to maintain and catch bugs in. So now that we've had a solid foundation, now that we have decent code quality, and we've fixed we've fixed the worst bugs, and we have steady improvements and implementing different small features of the CSS Flexbox spec. Let's do something cooler. So let's go add CSS Grid, and adding a whole new layouting algorithm to a library that was only designed to implement one has been really cool, and it's been really, really neat to see how we can expose that to GUI libraries and game engines and all of that in a way that makes the life better for their users. And so that's a lot of fun. But the next phase, and what the rest of this talk is going to ultimately be about, is what happens if we wanted to make Taffy a layout algorithm agnostic layouting engine, and to make it so then people could write their own layouting algorithms and use Taffy to help make them fast and to help provide a common interface, or to upstream them directly to Taffy. So if you guys are like, oh yeah, I really like Flutter's layouting algorithm, or I really like Swift UIs, like I really wish that it was implemented in Rust, like come say hi, we'll add it. So putting on my project manager hat for a little bit, like what happened here and what can we learn from it? So ultimately, I think that dead dependencies suck, and they're always going to suck. But if your dead dependency is open source rather than some proprietary binary blob, you can at least fix it. You could take ownership, and you can ask other people for help. And if you ask for help and make it clear that you're willing to share credit, that you're willing to work towards common goals, honestly, like, you can get, things become so much easier. Like for Taffy, I spent, you know, 3 weeks of engineering effort right at the beginning, making sure everything was clean, making sure fixing bugs, getting it in good shape. But after that, it's been a community effort. Like honestly, like, our lead engineer of this is Nico Burns, and he's just a contributor who showed up out of nowhere, and he has an unbelievable passion and talent for working with this really nitty-gritty, challenging code, and very, very, very thorough. And he's able to implement these performance improvements and bug fixes so much better. And, you know, from Bevy's perspective, it's like, great. It's kind of our problem, but we don't have to do it all ourselves. The next tip that I have is, when you're adopting legacy code, like, spend some time making it not suck before you try to add new features. This will make you much less frustrated, and it's a good way to get to learn the code base. The next tip is that when you're working on open source, just like everywhere, make sure as many things are automated as you possibly can. You need to have automated tests for correctness, because otherwise it's not going to scale. Because otherwise you're going to screw up, and you're going to take 1 step backwards for every 2 steps forwards. And finally, the last lesson is, Flexbox is deceptively complex. You're all web developers here. I'm sure you're well aware. So let's get into the second half of this talk. So why does layouting suck so much? It's talking to people learning web and learning UI and working with it in their day-to-day job. It's one of the most frustrating things that they bring up is, oh my God, layouting is so frustrating. Why are there so many knobs? Why is it so complex? Why is it so questionably documented? Why can't I center with this div? Why can't I get why is there a 1 pixel gap constantly? And I think that there are a lot of reasons for this. Some of them are very good and unavoidable, but some of them are just really some things that you can just fix. And so I want to talk about, as I talk about the problems and why I think that they exist, how can we fix it, and encourage you guys to, and the audience and everybody who watches this, to imagine a world where layouting didn't suck, where this was a joy and a pleasure to use, and you got to have those moments of, oh, wow, this is beautiful and perfectly responsive and does exactly what I want all of the time. So the fundamental reason why layouting is so hard is that displays are not all the same size, and secondarily, that content isn't the same size, and tertiarily, that the number of items in your UI may change dynamically, and all of this is to say that you can't have, like, layouting algorithms are not about how do I render pixels on a screen. They're not, because if they were, you would just have a very simple API that says, here, draw some boxes of this size at this position, and then you would just take a screenshot of your like Photoshop markups, and you would translate them directly into CSS. But you can't do that because those requirements of the screen changing size to support different devices, of windows getting resized, of dynamically responding to content, of dynamically like adding items to your list, those are really important. And ultimately, that's what layouting is about. Layouting is about being responsive. It's not about putting pixels on the screen. And when you are, and so when you make a change to one of your layouting parameters, sometimes it looks like it does nothing because you can't see what it's doing because you're only seeing a part of the solution space where it doesn't matter. But ultimately, UI layout is is describing this incredibly complex multidimensional function between the description of layout to how does layout, how do these pixels on the screen change with, how do these covary across different parameters? And that's what layouting is. And of course this is hard, of course it sucks, because what you're trying to do is fundamentally very, very complex. So let's talk a little bit more about Flexbox in particular and why the challenges exist. So a lot of the stuff that you might want to do in layouting is not easily exposed. They take an algorithms first approach to say, oh well, this is how we implemented the algorithms. Here's the different parameters we have. Okay, great. It's not okay. They didn't sit down and talk to designers and say, okay, what are the 10 most common operations you have? Let's go make an API for each of these and make sure that they compose nicely. And so you kind of, because it was implemented very iteratively and without a really like user-focused frame of mind, you get things like this, like the notorious how do I center a div, where you have the Stack Overflow post with like hundreds of answers and duplicates, and it's like, how is this possible? Like there should be one, maybe two ways to do this, and it should be the first thing that's presented in your documentation. So the other thing that makes Flexbox really hard for beginners is that the names are not intuitive. It's okay. If you pull a stranger off the street who's never done web dev, ask them which is justify left right or top bottom, and what about a line, or what does flex grow do, or flex basis, or flex shrink, or please tell me the difference between position static, position absolute, position fixed, and position relative, because none of those do quite what you might think. Or similarly, how does align items versus align contents different? Like, are items not contents? Are contents not items? And so my advice to you is, please just stick to horizontal and vertical. Just say, like, align horizontal, and try to avoid synonyms like static, absolute, and fixed, all in the same API. So the next one is something that, you can tell I'm a Rust developer, because it's make invalid state representable. It's things, your API should make it so then you can't have invalid states. You can't have a valid constructor, like you can't have a valid style where the min width is greater than the max width. And the really terrible thing here is that there's no validation. There's no panic for the developer that this must be the case. It's the layouting algorithm just has to handle it. And similarly, because all of the properties have to be very flat, there's no notion that okay, if this is set, then we must also set this, but otherwise we don't care about setting that. Like, it's all just a big flat list of properties, and if we're in the wrong state, it's silently ignored. And then we go and we change that state, and then suddenly all of these properties that we thought we didn't care about are now being applied via overly permissive selectors or something. And it causes just a tremendous amount of challenge. And a lot of this comes from the fact that CSS, that Flexbox comes from the web, and the web is notoriously permissive. It says, you did something wrong? Well, I'm going to try my best. I'm going to guess to see what maybe you want. And so this invalid state being representable causes a lot of problems. Like, you'll change a value, like in your inspector, and you'll say, what does that do? I want to see what that does. And nothing changes. And you're like, well, okay. And that's a terrible learning experience. You'll have things where you'll change one property and will silently toggle off another, or you'll toggle on a property and then it will activate all these other properties that were set to garbage values. And because layouting can't fail, because we're not doing validation checking, everything has to result in a layout, even if it's ugly or useless or doesn't make any sense. And similarly, you get redundancy in your layout definitions, where you have different ways to define the same layout that will behave identically for every possible set of inputs, but have dramatically different performance characteristics. And this is both a flaw, but also a foot gun, and it should tell you, for those who are mathematically inclined, that something is deeply wrong here. So my suggestion is, please use a real programming language that has sum types. Sum types are really good. Like, if you want to represent data and you want to say it can be in one of these states, please just put it in a sum type, put it in an enum. Don't use stringly typed enums. It's bad. And try to think carefully about your data structures and nest them. It works really well, and it helps you represent the states better. So the next problem here is that a lot of these problems can't be fixed. You'll get yet another layouting solution for CSS instead. I think we're at least up to 3 now, and this is because of the unique properties of the web, where at some point we have decreed that it is morally wrong to break old websites, which, you know, is both good and bad. And so we can't do the thing that other software gets to do, where it slowly refined its API and design in response to user feedback to say, you know what, that was actually a mistake. Let's rename this field. Let's go cut this behavior because nobody actually uses it. It just sits there and accumulates junk, and it just and these problems that everybody agrees are problems cannot be fixed. So don't design an algorithm assuming that it's going to be perfect from the start, because similarly on the web, having a solution that mostly exists, that mostly works, makes it very hard for anyone else to make something better. Because I see this even within the Bevy community. I'm like, okay, Flexbox is kind of bad. We should use something else. We should spend some engineering effort making an actually user-friendly and intuitive layouting system. And the question is, and then people are like, okay, but Flexbox already exists. But people already know Flexbox, and so you get you have a stifling effect, because not only does an existing solution exist, it's a solution that we can't just make better. And this kind of gets into this point is really inspired by my time working with implementing and designing Taffy, and saying, okay, here's the specification and of how Flexbox should work, and the way it's described is very, very algorithmic. They say, first you do this, then you do this, then you do this, and you have this intermediate variable. And it's clear that what happened here is some engineers coded up a solution, and they said, okay, well, here it is. Look, it behaves pretty reasonably. And then they sat down, and then they wrote the spec by translating the implementation into pseudocode. And this is a bad way to write references and to write specifications. Don't do this. Have some, have a principled idea of what you're going to work on, how it's going to work, and why, and then have several people write competing implementations and see if they all agree. If they don't agree, then your specification is wrong. It's broken, because a specification should not rely on comparing to an existing algorithm. It shouldn't rely on validation in that way. We should be able to tell what's a bug and what's an intended behavior without very clearly. Like it should be clearly obvious, and it should be defined in the specification. All of the edge cases should be covered, and rather than saying, okay, well, this behavior exists in Chrome, and do they consider it a bug? Is this a bug because, is this accepted just because now people are relying on it, rather than because anybody ever consciously decided this should be a feature? So it's try to, I know it's hard, and I know it's easier said than done, but spend some time thinking about the properties that you want it to have, and the overall architecture, and make something beautiful. So the next question, the next problem is again fundamental to how layouting works. We're dealing with trees, we're dealing with graphs, and if you can look both up and down the tree in your layouting algorithm, you are going to get exponential behavior unless you are very, very, very careful. And looking up and down the tree is extremely useful. You want to know how big your parent is. You want to know how big your child is. You want to go and be able to respond and compromise. But ultimately, if you need to use very careful caching to do this. And so if you want to go and say, okay, we're going to propose an extension, we're going to go propose a new feature, but if you screw it up, then you'll get exponential behavior. It really changes how you design algorithms and how you design features for this, because in order to say, yes, we're going to do this, it has to be provably efficient. It has to be provably non-exponential. And, well, it's how do you prove that something is not exponential? And in a system of any complexity, and in a system without a lot of elegance, the only good way to do that is to write the code and then measure it. And so this ultimately leads to this really tight coupling between the spec and implementation that I described in the last slide. So if you want to write a layouting engine and layouting algorithms, Flutter does really cool things. They limit the number of layouting passes as a design constraint, because they say, well, this could be convenient, but dealing with caching and dealing with exponential blowups sucks so much that we're going to say all of those features that could possibly require this are impossible. But this is where I think it starts to get really interesting. So I come from a pretty mathematical background, and I look at a problem like layouting, and I say, why are you doing it this way? You have this beautiful, precise, deterministic algorithm, and then you round to the nearest pixel? Why do you care about infinite perfect precision? You just want an approximate solution. And it turns out that approximate solutions can be asymptotically faster than exact solutions to the same problem, even on exponential things. And if we're rounding the final result in the end anyways, I think that there should be genuine effort exploring approximate and algorithms for layout driven by mathematical optimization, or even driven by machine learning and gradient descent or neural nets. Because, again, layouting is just a function that transforms an input into a result. We know how to work with these. We can borrow from LaTeX and define an objective function to say, how bad is it to be wrong in various ways? What are our penalties? And you can just use general optimizers to search this sort of solution space, at least as a first approach. And because you have this function and the subjective function as decoupled from your optimizer, you can go and replace them. You can go and experiment with them. You can say, oh, well, I want ChatGPT to try their hand at writing an algorithm to optimize my layout. Or you say, okay, well, actually, I think that this is amenable to linear programming or whatever. This is an idea that dates back to 2001 in Cassowary, which uses a linear programming to solve its layout. But nobody took that, never caught on. And I think that this was a great idea that really is ready for another try. And ultimately, when you're trying to design this for mathematical optimization, you want a lot of the same properties that humans want. You want continuity, you want smoothness, you want orthogonality of inputs, so then when you change one property, other things don't get changed. And these properties that make an algorithm responsive, a API responsive and easy to learn and intuitive, also help mathematical optimizers. So I think so this is kind of an open question, an open challenge, a mad science idea. But I think that this is what the future of layout is going to look like. So, in summary, let's talk about how might we make our new layout algorithm not suck. So first, controversial, but you should think about what your users need rather than starting from an algorithm. Secondly, I think you should carefully design your input space so invalid states can't be represented, and that this is really at the heart of making everything else work. So then you want to say, okay, what does each parameter do? By going and writing docs. Go before you do your code, try to write docs to explain to users what it does. If you need lots of complex language and lots of if cases, your algorithm is probably inelegant and your API is definitely going to be confusing to them. So you should go back to the drawing board before you try and code this up. Then you should go and write some tests and for the basic behavior and edge cases, and then implement your algorithm. Next, you hand it to the users, you listen to their feedback, you go and you make your thing better, because ultimately these things are designed to be used by users, and we know that they are incredibly hard to use. They're incredibly hard to learn. They're frustrating and tedious. And then you go, you take that feedback, you fix the stupid footguns, and you change it, and you say, sorry, users, I'm implementing version 2.0 of this algorithm. You can't, your previous code is going to break. And you do this over and over again until you have something that users understand, that users are happy with, and you repeat, and then you ship it. And then finally, once you have this spec, go make sure that the spec itself is good by asking for people to do independent implementations. And finally, I think that optimization-based layouting is a really cool idea, and if anybody wants to collaborate and explore it with me, I would be happy to take a crack at it. So yeah, that's all I have for you today about Taffy, and I hope that there is a future where layouting doesn't suck.